Hi, as you have seen during my poster teaser, the goal of my research is to repurpose antidiabetic drugs as radiosensitizers. Metformin and fenfluramine are two antidiabetic drugs that have been used since the 1950s. Metformin is still being given to 80% of diabetic patients today, while fenfluramine has been retracted from clinical use since the 1970s due to severe side effects. In my first panel of figures, you can see the radiosensitizing curves. On the y-axis, we have the surviving fraction, which is in log scale, which means that 10 to the minus 1 you have 90% cell kill, 10 to the minus 2 you have 99% cell kill, and so on. On the x-axis, you have the radiation dose, which is in gray. Cells under hypoxic conditions are more radioresistant than under aerobic conditions, which means that you have to radiate with a higher dose to have the same amount of cell kill as under aerobic conditions. In my panel 1, you can clearly see that metformin and fenfluramine have a radiosensitizing effect because they shift the curve to the left, which means that the cells become more radiosensitive. Our main hypothesis is that metformin and fenfluramine inhibit complex 1 of the mitochondria, which leads to a lowering of the oxygen consumption rate, which abolishes hypoxia inside the tumor. We tested this by seahorse. First, we measured the mitochondrial complexes. This, as you can see in panel 2, figure A, there is a clear inhibiting effect of metformin and fenfluramine on the oxygen consumption rate of the complex 1. There is no effect of metformin and fenfluramine on the other complexes. This is data that has not been shown on the poster. Secondly, we measured the oxygen consumption rate of the tumor cells in real time. You see, after injecting metformin and fenfluramine in the medium of the cells, the oxygen consumption rate drops, and this correlates with the radiosensitizing curves of panel 1. Next, we went on to validate this in vivo. We injected CD26 cells in the hind leg of a BALB/C mice. After these tumors were grown enough, we started treatment of the mice by oral device with metformin and fenfluramine. After 1 hour of treatment, we radiated the mice, but we only radiated the hind leg, so the rest of the mice is not radiated. After radiation, we treated for another 9 days. You can see in panel 3 that both metformin and fenfluramine on their own have no effect on the tumor growth, while in combination with radiotherapy, there is a clear tumor growth delay of both metformin and fenfluramine. The next step was to look inside the tumors and to look at the hypoxic fraction. We did this by primolidazole staining. Primolidazole is a known hypoxia marker. It seems that fenfluramine, even after 1 hour of treatment, has a lowering effect of the hypoxia. The experiments with metformin are now being done. So to conclude, we have first that metformin and fenfluramine have a radiosensitizing effect on the cells. Second, there is an oxygen sparing of the tumor cells by inhibiting of complex 1. Third, we validated the tumor growth delay in vivo. Fourth, we saw that fenfluramine has a lowering effect of the hypoxia inside the tumor. If you have questions, you can comment below.